There are four FHIR paradigms to accommodate different workflows. They are the FHIR REST API, FHIR Messages, FHIR Documents, and FHIR-based web services. We will not cover message or document-based exchange, but you should be aware that they exist and are potential replacements for the earlier HL7 messaging and document standards we have discussed. I refer you to the FHIR site for a discussion of these paradigms. The site also discusses the potential use of FHIR in web services based on other service-oriented architectures. The FHIR API paradigm uses representational state transfer, REST, that relies on a client-server stateless cacheable communications protocol, typically using HTTP. Here you see a simple illustration of the FHIR HTTP format. The endpoint or base is the address of the FHIR server. This is followed by a resource type and its resource ID. This example would find the patient with a resource ID of 1 on this particular FHIR server. I assume anyone taking this course knows what client-server architecture is. As shown here, statelessness essentially means that the necessary information to handle a request is contained within the request itself. This might be as part of the URI, query string parameters, body, or headers. Thus, with no prior knowledge and no need to remember the transaction, any machine in a vast server farm could handle the request, return the appropriate response, and be available for the next request. The response from the server to the client is similarly self-contained. Clients can cache responses. Well-managed caching partly or completely eliminates some client-server interactions, further improving scalability and performance. In FHIR, the four HTTP verbs post, get, put, and delete implement CRUD. Post creates new resources. Get reads existing resources. Put and delete update or remove existing resources. Here you see a complete list of the currently defined logical FHIR interactions. This part of the standard is at maturity level 5, so it's essentially in final form. Note the three sections: instance, type, and whole system interactions. In the instance section, note that patch, a fifth HTTP verb, can be used when a client is seeking to minimize its bandwidth utilization, or in the scenario that a client has only partial access or support for a resource. This might be the case in healthcare, given the emphasis on privacy and security. In the type section, note that FHIR defines two interactions of particular interest in healthcare. History retrieves the sequence of prior instances of either a particular FHIR resource, all resources of a given type, or all resources supported by the system. History can be quite useful given the clinical importance of trends and changes in patient status. This is a good place to explain FHIR bundles. These are a collection of resources into a single instance along with some context information. For history of a patient's blood pressure, without specifying a time period, the server would send an observation resource bundle containing all of the past measurements. However, a bundle need not consist of the same resources, so one representing some summary of a patient's record would likely contain many different resource types and values. Here's an example of that using the public HAPI server. A search for the observations for patient 10506 has found 12 of them. Here is the accompanying JSON. You can see at the top that it is a resource bundle. Next is the context information to put what follows in the proper perspective. The first observation is a systolic blood pressure of 130 millimeters of mercury. The next one is for heart rate, a clinically different observation. The value is off screen, but should you be curious, it's 68 beats per minute. Also, in the type section, search is a particularly rich and important part of the FHIR standard. In the simplest case, a search is executed using a get operation where one or more name equals value pairs encoded in the URL specify the parameters. You can explore search using the forms provided on Graham Greaves' FHIR server. This is part of the extensive list of search criteria for patients supported by the server. As you can see, I have asked for all females born in 1955. I get this one result, Eve, every woman. Try this yourself, and right after the server base URL, you will find patient / specifying the resource to search. If you look carefully in the long string that follows, you will find birth date equals 1955 and gender equals female, the two operative name equals value pairs. When you try it, keep in mind that the data on public servers can change, so this particular example may or may not work as it does here. Searches are constrained to one of three contexts in order to control what resources are considered. I'll discuss each and show you the applicable format. A specified resource type, as in the example we just did, where this was patient resources. A specified compartment that might be a specific patient, perhaps with a specified resource type in that compartment. We did that earlier when we looked for observations for only patient 10506. All resource types, where the parameters must, of course, be common to all the resource types.